Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. This is our question show. Your questions, my answers. Now, wherever you are across my channel, if a question pops in your brain, just write it down and I gather them up and I answer them here. But we also record this show live every Monday at 5 p.m. Pacific time. So if you want to come and join the live show, ask your questions, follow-up questions, stuff I've never seen, definitely come and join us on Monday at 5 p.m. All right, let's get into the questions. Mr. Dobalina. Hi, I have a question. What is the difference between the observable universe and the Hubble sphere? Great question. Now, I did a whole episode with Dr. Paul Sutter where we went through this entire process and discussed what is the difference between the different kinds of cosmic horizons, from the observable universe to the Hubble sphere to other various cosmic horizons. So I'll put a link to that in the show notes. But the question that you asked is, what is the difference between the observable universe and the Hubble sphere? So the observable universe, of course, is the region of the universe that we can see that is within the amount of time that has taken light to travel from the Big Bang to here. And that is about 13.8 billion years of time. But the universe has been expanding and the galaxies have been moving and the Milky Way has been moving. And when you add up all of that, you get about 94 billion light years across for the size of the observable universe. And so objects which are half of that, so about 46 billion light years in one direction, the galaxies that are there, or I guess the cosmic microwave background that is there, is almost the beginning of the universe. And the light has been traveling to us for 13.8 billion years. And the universe has been expanding and the galaxies have been moving. And so that's how you get this distance. And it's sort of, when you think about it, right, like shortly after the Big Bang, sort of during the era of inflation, the entire observable universe was about the size of a golf ball. But it wasn't the whole universe. There was more universe around it. So imagine like an infinite universe and just this tiny golf ball sized chunk in the middle of this infinite universe. And that one little piece has expanded up to the observable universe that we see today. But you could move over one golf ball size and get a completely different observable universe that doesn't overlap with our observable universe at all. It kind of blows the mind. So the Hubble sphere, the Hubble volume, this is the region of space where the galaxies are essentially reachable by the speed of light. And so beyond that region, galaxies are starting to fall over the cosmic horizon that, due to the expansion of the universe, they are, from our perspective, moving faster than the speed of light to us. And it's actually a much smaller volume than the observable universe. If you sort of like divided the two, about 94% of the observable universe is unreachable, is over that cosmic horizon. And so these galaxies, they're there, we can see them, but we could never get to them, even if we could go the speed of light. And they will fade away, redshift into the red as their wavelengths of the photons stretch out, and they will effectively disappear from our view. And over time, more and more of the universe will fall over that cosmic horizon and disappear. Moochie the cat. What are the ramifications of satellite access for consumer-grade devices? So we saw this week that Apple's iPhone 14 is going to be allowing you to send an SOS call on a satellite network on Globalstar, and Starlink and T-Mobile have announced that you're going to be able to make satellite phone, again, in the beginning, you'll be able to make text messages, but eventually you'll be able to make phone calls on their service. So like, what are the ramifications? Well, this is the satellite networks today. You can imagine over time, as the satellite networks get bigger and more complete, then they'll be able to offer more and more bandwidth. The thing that was really surprising to me with the Starlink, and actually there was a company called Link that we've written a couple of stories about on Universe Today. They actually built a CubeSat that has been able to connect to cell phones as it's flying overhead. And when you think about it, like, space is just there's no obstacles between you and space. It's just the strength of the signal. And so as long as your phone can reach the satellite and vice versa, then you can theoretically connect back and forth. And obviously we're in the very initial stages of this, but like, do you remember when you first got Wi-Fi, or, you know, for the people who were alive when Wi-Fi showed up, as opposed to the kids where Wi-Fi has just always been around, and it sucked and it was slow and it barely worked. And yet it was still kind of magic that you could be not on a wire and be able to use a device like your laptop computer. And so obviously we're just going to be marching headlong into this world where every device that you own will either connect to a Wi-Fi point or be able to connect to the satellite network. And no matter where you're going to be on Earth, you'll be able to connect. I have this like story. I was driving in the US with my kids, and we were like on a big long road trip, and it was about like 10 years ago or so. And we were trying to get Wi-Fi to book a hotel. And so we had to park in a McDonald's parking lot to try and get their Wi-Fi. And I was like laughing with the kids saying like, kids, just remember this day, because this will be the look back hilariously that your dad had to figure out a way to be able to connect to the internet so he could book a hotel room, and that problem will go away. And now your cell phone through the cell phone towers is very fast. You can watch videos, etc. The next step, of course, is that you'll be able to do this anywhere on Earth. So, I mean, what are the ramifications? You can be hiking in the middle of the forest. You can be out in the middle of the ocean. You could be sailing around the world. You could be in the middle of a desert, and you'll still have high-speed internet. You'll still be able to connect. People won't get lost as easily, I guess. It's hard to say. I mean, this is one of those technologies that is going to come quickly. We're not going to really appreciate all of the ramifications of it until it's really deeply embedded into our society and our culture. Obviously, the downside is that there's going to be 42,000 satellites from Starlink. There's going to be thousands from Kuiper and the other satellite networks. So far, they're not hampering the sky for your regular eyes. They're definitely hampering the sky for telescopes. There's a few upcoming satellite networks which could be devastating for the view of the night sky, like really bright satellites. So I really hope that they don't happen. So the other ramification is that if they get big enough and bright enough, then they could fill the sky with satellites. But if the path continues today, like if we get Starlink-sized satellites communicating with the Earth, it should probably be fine. But in order to make this cell phone network work, they got to use the next generation of Starlinks, and they're bigger, probably brighter. So I think the ramifications are we get to communicate with the internet anywhere on Earth, and the night sky is taken away from us just a little bit more. Alexandru Vataman. How does Jupiter's magnetosphere affect the expected life on Europa's oceans? Why are scientists still expecting life with such conditions? Thanks. The magnetic field around Jupiter is much stronger than the one that we have on Earth. And the same thing that happens, this idea of like the Van Allen belts, this trapped radiation belt is there at Jupiter, but it is much more severe. And it's so severe that when NASA plans the trajectory for its spacecraft, they try to make them spend the absolute minimum amount of time passing through these really intense radiation belts. Europa happens to be just bathed in this radiation. If you were out on the surface of Europa, you would receive a lethal dose of radiation within 24 hours. Like it's deadly. Something like 1,800 times as much radiation as what you would experience just out in space somewhere else. So it's bad. But water is an incredibly good protector against radiation. It's just as long as you got a lot of protons, you've got good protection from radiation. And about a meter of water, or ice in this case, is enough to protect you completely from the effects of Jupiter's radiation. And not to mention Jupiter's radiation, solar storms, cosmic rays, you are completely protected. And so when we think about life on Europa that could be hundreds of kilometers underneath the ice, no radiation is getting through that. Now, if we do send a mission to Europa, the risk is going to be, can we have the spacecraft land on the surface of Europa and even survive. But one of the benefits is that if we did bring any nasty Earth life with us, it's going to be bathed in radiation and it could sterilize the spacecraft. But one of the issues is this layer between the surface of Europa and under the ice. And if we send a lander with a drill that's going to attempt to search for life on Europa, you're exactly right. If we can only dig down within that first meter of the ice, we're not going to be able to find anything because everything is going to be irradiated. So any mission that's going to be searching for life on Europa has got to be able to dig down more than a couple of meters. Ideally, dozens of kilometers to reach the subsurface ocean, but still, if you can at least go a couple of meters down. And this idea of water is one of the best ideas for just protecting human beings from radiation in space. Like if you want to go on a mission to some place in the outer solar system and you can take a couple of years, enclose your spacecraft in water ice. Let it freeze. It's both your source of water, it's your source of air if you need to. You can break it up. It's your source of propellant, and it is your radiation shielding. Water's great. Pat Lev. Lunar poles. Information? Question. I mean, you didn't really ask a very specific question, so I'm just going to generally go on about the poles of the moon, and hopefully you will be able to pluck out the answers that you were hoping for. But the moon's poles are the places where scientists believe, or kind of know at this point, they are in permanent shadow and that there are deposits of water ice that are located at the poles of the moon. And so the moon is within the frost line of the solar system. And so the intense radiation of the sun will vaporize any water ice that is just sitting out. Like if you had an ice cube sitting out on the moon, it would sublimate away into space. But around the poles, because the moon orbits around the Earth and it has these craters at the north and south pole, as well as mountains, and they cast these long shadows that keep regions inside those craters permanently shadowed. And NASA and other groups have sent spacecraft to the moon, and they've been able to detect water ice. The Indian Chandrayaan mission was the first spacecraft to actually detect the presence of this water ice on the moon. And so this is the target for upcoming lunar exploration. Both China and NASA have targeted the south pole of the moon as the best place to go to send humans. That if you could actually sit down on the moon, you could bring some kind of gear and technology to be able to extract water ice out of that permanently shadowed craters. You could replenish your fuel supplies, replenish your water, your oxygen. Water is like really important when you get out into space. And so that is why the moon is so exciting. And so within the next couple of years, we should see the first humans set foot on the moon. In 50 years, we should see them search around to see if they can find these water ice deposits. And over time, hopefully, we will see methods and techniques and technologies for extracting this water and create a sustainable lunar base. So I hope that answered your question, or other questions that you might have had, or questions you didn't even know you had. Amir Kal. Hey Fraser, you as a person who follows amateur astronomy and uses Starlink as your daily internet connection, what do you tell people who oppose Starlink and its drawbacks? Yeah, I think that there is a overly simplistic argument about Starlink. So on the one hand, half the people on Earth have no access to the internet. And by not having access to the internet, they are being left behind in this globalization. They don't have access to the bank. They don't have access to the library. They don't have access to medical information, to be able to talk to their doctor, to be able to connect with their friends. Just educate themselves in the technology that is kind of required and really gives you an edge. And if you have the internet, then you can research anything, connect to anybody. And if you don't have the internet, then you're permanently kind of left behind. And the rich get richer and the poor get poorer. And the internet is the method for equalizing wealth on Earth. If you have ambition, you can connect to the internet, you can do incredible things. And if you just can't, you're left out. So I think that access to the internet is key for just society and for people around the world. And so that is the promise that these internet companies have made is that we're going to connect the rest of the world to the internet, and this is the societal good. So if that was true, then that would be fantastic. But of course, like, these are big companies, and, you know, do we trust them? And are they actually going to do it? Or are they just going to make as much money as possible and extract resources the way they always do? So that is the sort of cynical view about what they're doing. Now, the downsides are, I think, also overhyped. So with the Starlinks, for example, the brightness of the Starlinks, they are so dim that you can't see them. Now, you can see them when they're launching in these trails as they are shifting up to their higher altitude, but you can't see them once they've reached their altitude. You can only see them with a telescope. And they're only visible when they're close to the horizon during dawn and sunset. So in the middle of the night, the darkest times, the times when it's best to look at the sky, you can't see the Starlinks or any of the other satellites that are up there. They're just a nuisance in the sort of beginning of the evening and just before sunrise. But there are really important science work that's being done that needs that time. And so a good example of that is people who are searching for dangerous asteroids. The most scary, terrifying asteroids out there are the ones that we don't see, the ones that pop out of nowhere because they're coming at us from the sun. And that means that you need to be able to view them early in the morning or just after the sun goes down near the horizon. And you've got to do these giant surveys where you're looking at frame after frame after frame of the sky. And it's really easy to get a Starlink passing through, obscuring your view to the asteroid. And it's probably happened that people have searched the sky and they didn't see an asteroid there, but actually there was one, but it was blocked by the trail of the Starlink. So right now there are a couple of thousand. Imagine what that's going to be like when there's 42,000 of them, just Starlinks, not to mention the other satellite networks. And then the other issue is the astronomers, you know, the ones that are doing, say, work with the Vera Rubin or these other giant surveys that are doing observations on galaxies and so on. They are going to have multiple paths going through their views, and it's going to be degrading the quality of the science that they can do. And so I think if you came to me and said, every person on Earth will be able to connect to the internet at a reasonable price and be able to join in this global interaction, and the price that you would have to pay is severely degraded ground astronomy, it's a price I would pay. Because, I mean, astronomy is great, but helping people in Africa connect to science databases so that they can figure out ways to clean their water is important. So I think where everything went wrong is that all of these satellite companies got a chance to launch without fulfilling on that promise, without making a deal that they can't back out of, a contract that they can't avoid. Like, imagine if a new satellite company came along and they said, we're going to let the whole world connect. And the government said, okay, fine, put up several $1 billion as an escrow. And if you don't connect people to the internet at this price that you promised, then you forfeit that money and your company goes into bankruptcy because you had one job and you failed in that one job. And instead of connecting to the world to internet, you made yourselves rich. And so the price you have to pay is you lose it. So I think that it all came so quickly that we didn't get a chance to put brakes, to have discussions, coordinate activity, and really put the hooks into these satellite providers to fulfill on that promise of giving the world connectivity. So that's my fairly nuanced view of this entire situation. And the problem is now the horse is out of the barn. The satellite operators are launching their satellites. They're connecting. They're providing high-speed internet. I don't think underserved regions of the planet are getting their internet yet. And astronomers are losing their skies. So I hope someone is able to figure out a proper balance. More conversation should be had. More agreements should have been made. This is a shared good. We see this problem happen again and again and again, right? It's the air, it's the waters, it's the oceans, it's the common, well, what's the term? Tragedy of the commons. Again. And now it's going to be space. So the other issue that a lot of people are worried about is space junk. And actually, that's not a big problem. The satellites fly so low that they have to be constantly raising their altitude. And if they don't, then they will crash into the atmosphere and burn up within a couple of years. It's actually a great region of the sky to put satellites because it's self-cleaning. It's the ones at much higher altitudes, ones that are thousands of kilometers high, the ones that will stay for hundreds, thousands, tens of thousands of years. And if they smash into each other, there's really no way to clean it up. So I would rather have satellites go into low Earth orbit, really close to the Earth, than the ones that are higher. So, and then the other thing is, like, if you're not going to use a satellite, what are your options, right? To reach the rest of the world? Are you going to use cell phone towers? Well, cell phone towers kill birds. They are an eyesore. They take up an enormous amount of metal and waste products. They don't last very long. They have to be replaced, etc. Are you going to bury cables in the ground? You got to dig up through sensitive environments. You got to dig up marine environments to lay cables through the oceans. Like, launching satellites seems to be the lowest impact way of connecting the world to the internet. And there are some issues with it, and they should have been negotiated. So that is my highly nuanced view of satellite internet companies. And of course, I am using Starlink right now for like one more month, and then they're gone. But I depend on it. And I wouldn't be able to do this job if it wasn't for Starlink. So here we are. Don't cut me off, Elon. More questions in a second, but first I'd like to thank our patrons: Brian, Patrick Madden, Douglas Bell, King Petway, Fred Dunn, Sergio Sansevero, David Barnes, Jeffrey Miller, and the rest of our 1,038 patrons for their generous support. Want our videos with no ads? Join our community at patreon.com/Universe Today. And I'll also remove all the ads from the Universe Today website for life. Old Gamer Noob: which is more dangerous to Earth, a comet because of its high speed but lower melting point, or asteroids being slower but having a higher melting point? Comets. Comets are way more dangerous than asteroids for a couple of reasons. So the first one is trajectory. So when you have an asteroid, you have a lot of warning, generally, because the asteroid is just in orbit. It's been orbiting around us for thousands of years, tens of thousands of years. And as astronomers map out the region in the sky, they are able to pin down every single dangerous asteroid. And we're at the point now, actually, where every really dangerous asteroid has been identified. You know, all the ones that will take out a continent. So now we're down to the city killers that are still unknown and out there. But over time, they will be found. They'll be mapped out, and we will know the location of every single dangerous asteroid that's out there. Comets come out of nowhere. And you have no, like, for the long period comets, that's their first trip into the inner solar system, and you have no way of predicting. And so you just get a few months notice before the comet arrives and ruins your day. The speed is an issue. So the asteroids are moving slower, the comets are moving much faster. And at the end of the day, it's about the amount of damage. The energy released is a function of both the mass and the velocity. And when the velocity is higher and the mass is the same, then the amount of energy that's released is much greater. Yeah, so comets are a little more terrifying than asteroids. Disasterina: how do you see climate change affecting the space industry over the next 10 years? So there's a couple of issues with the space industry that we're already dealing with. The first one is that obviously a rocket that is flying with methane or jet fuel, right, is in putting out carbon dioxide and other greenhouse gases. Now, the amount isn't a lot, but if you imagine this world where Starship is flying multiple times a day, you've got multiple rockets around the world, and a rocket is just a giant tube of fuel, it's big. And it'll have a non-zero impact. Now, SpaceX has said they want to move to this world where they're generating all of their methane on site using solar power, and they're pulling it out of the atmosphere. Sounds good. Sounds far-fetched. It's tricky to do that amount of methane production out of the atmosphere at that kind of scale where you're filling up a giant rocket multiple times a day. So you've got just the carbon emissions. But the other issue is that rockets put out emissions into a region of the atmosphere that nothing else is deposited. So they're actually putting it up in I think it's the troposphere. As a rocket passes up through the troposphere, it's putting out particulate and putting out material into that region. And that has an impact on the Earth's climate. And then you've got, of course, all of the production of the rocket and all of the material involved and all of that. And then the thing you wouldn't really think about is sea level rise. So you've got Cape Canaveral, you've got Boca Chica, you've got the site in South America for the European Space Agency, you've got where the Chinese launch from. A lot of these places are at the coast on very low areas. Big chunks of Florida are going to be inundated over the coming decades as the sea levels rise. Boca Chica is going to have its problems too. And so imagine having to completely move Cape Canaveral to another location because now it's just underwater too often that you can't launch rockets there. So I think that obviously, like any industry, the rocket industry is going to have both, it's a contributor to climate change and it's going to be impacted by climate change. And there's kind of no way around it. Pray for our country. Lunar Gateway or moon base? My vote is moon base. Well, it's not an either or. Like, the whole point of the Lunar Gateway is to make a moon base easier. It's kind of like saying a base in Antarctica or a port at the bottom of South Africa, right? Like being able to fly down to South Africa, hop in a boat, and then go to Antarctica is vastly more convenient than attempting to just fly to Antarctica or take your boat from, I don't know, Europe all the way down to Antarctica. And so the Lunar Gateway, if it works the way it's envisioned, is that you've got this stepping stone point, this space station that is orbiting close to the moon. It's not orbiting around the moon, but it comes close to the moon on a regular basis. And then you've got the lander that's detaching from the Lunar Gateway, flying down to the moon, landing. The astronauts are hopping out, collecting rocks, jumping around on the moon, looking for that water ice that we talked about before, and then they get back in the lunar lander and they fly back up to the base. And the whole thing is reusable. And then you've got a ferry that carries you from the Earth to the Lunar Gateway. And maybe that's also Starship, something that's fully reusable. And so when you think about the Apollo era, like the whole stack of the Saturn V and the capsules, that whole thing was thrown away. And the only part that made it back to Earth was just the little capsule on the top. And with the new system, in theory, you've got a reusable first stage rocket. If you launch with, say, a Falcon Heavy, like I'm not like, forget about SLS. I mean, obviously that's how it's going to work today, but that's not the vision, I think, in the long term. You've got Starship, which is fully reusable two-stage rocket, or you've got Falcon Heavy, which is mostly reusable. It's launching a capsule, maybe a Crew Dragon or an Orion. It docks with the space station. The astronauts get out. They move over to the Starship. They land on the surface of the moon, come back up to this gateway, back down to the Earth. And so much is reused that it goes from this giant stack that you're throwing away to a renewable system that's taking you to and from the moon. And that's how you build a base. Each launch carries more and more material down to the surface of the moon through this ferry system, and you build up a base. And then you've got a base where they're producing propellant on the surface of the moon. And so when the lander lands, it refuels. And in fact, it carries even more fuel back up to the Lunar Gateway. And then it can, as other spacecraft attach to the Lunar Gateway, they can be refueled. Like it's that infrastructure that you always imagined the future of space exploration could be. And that's what it's going to take for us to go to space and to stay in space, to go to the moon and stay on the moon and not just go, it's too expensive. Let's go home and do something else. Let's build a space truck. So yeah, both. You get the Lunar Gateway and then you build the moon base, and the two work together in tandem. And the Gateway really is a gateway to the rest of the solar system. And so you can then, your Starship, your tanker is filling up propellant. It flies up to the gateway. You've got the Mars spacecraft arrives at the lunar gateway. Now it's almost out of the Earth's gravity well, and then it tanks up and then flies off to Mars. And all it had to do was carry like a little bit of fuel for the people, and that's it. So yeah, it's a pretty cool future if we get there. Christopher Bergen. How likely do you think it is for Congress to allow nuclear rockets to get astronauts to Mars and deeper in space without as much cosmic radiation? The chances are pretty good at this point. Now, nuclear rockets, this is an idea that's been around for decades. I just go back to like every good idea was thought of back in the 60s, and nuclear rockets were developed like back in the 60s and 70s and have been tested for decades, and they work great. You have a fission reactor, you heat up some kind of propellant like hydrogen, you blast it out the back of the rocket, you get a huge specific impulse, much better than a chemical rocket. You could cut down the travel times to and from Mars by a couple of months. They're a great idea. Now, the downside, of course, is you're launching a fission reactor as a rocket. And so the idea that's been proposed is that you fly the thing to space and then you turn it on while you're in space. And, space is already filled with radiation, so who cares? And so even though this technology has been around for decades, it's nuclear, it's scary. And so they stopped working on that and focused on traditional chemical propellants. But people are becoming more and more comfortable with the idea. And in fact, fairly recently, NASA and I think the US Department of Defense have been handing out grants for people to actually start developing nuclear rockets and nuclear reactors that can be used on the moon. And so I wouldn't be surprised if in the next decade we see an actual nuclear rocket used in space as a prototype. And the Chinese are working this as well. They've announced they're going to be sending a mission to Neptune, and they're going to be using a fission reactor as the way of getting out there. And it's like one of the few ways you can get that far that quickly and to be able to do it and give you tons and tons of electricity to be able to use for your mission, for all of your science instruments and so on. There's no cost cutting required in terms of energy. You got all the energy you can handle. And actually, the Soviets launched a bunch of fission reactors into space. I think they launched like 20 plus reactors. One crashed into Canada, and we're still cleaning it up. The Americans have launched one fission reactor into space. So the technology has been around for a long time, and it's just a matter of both putting in enough safety issues that people are comfortable with this working, and also working out the technical details. But this is what you do, right? You build prototypes, you test them out, and you learn your lessons, and eventually it becomes good enough for humans to fly on. So yeah, I think we're going to see nuclear rockets sooner than later. John Stuffel. Well, why do conspiracy theorists always point at NASA when there's so many other space agencies around the world? NASA's and everything. That's a great question, and I'm going to be talking to Lee next week about science denialism. It is weird to me. Like, I think it's religious. Is the impression that I get is that the concept of the Big Bang, of space, and of a spherical Earth, etc., runs counter to things that are said in the Bible about the age of the universe, how it came about, as well as this idea of the firmament above the planet and blah, blah, blah. And so for people who take their religion very seriously, they have to run up against what science is saying that is different. And obviously for most people, I'm sure there's a bunch of religious people in the audience right now, and you just adapt. You're like, obviously it was metaphorical, and obviously they didn't know the shape of the Earth, and maybe the firmament's a different thing. Anyway, but for people who take it very fundamentally, they have to choose their belief over what nature is trying to tell them. And when we hold these beliefs in our brain at the same time, these two thoughts at the same time, they can't hold together. And so you look for anything that confirms your prior belief. You look for conspiracies. You look for pictures and you look for people who believe the same things that you are, so you can talk to them and agree with each other and confirm each other's beliefs. That's how you get there. And so I think space, NASA, the origin of the universe, like, it is treading in the same places as religion. It's asking these fundamental questions about how old is the universe and what is our place in the cosmos and how do we get here? How did life form? Is life across the universe? And so if you have these beliefs that have been told to you and they are your worldview and they form a big chunk of your personality, it's very difficult to listen to someone who is attempting to tell you something different, and they get angry and they lash out. And like my Facebook comments are just a mess of flat earthers and conspiracy theorists and science deniers. The chat here is often a mess of that kind of a thing. So I think, like, I would love to have a productive conversation with some of the people who believe these things. And like, I just want to understand. I want to ask them questions. But I know that it wouldn't be super fun. It would go bad because, like I know I'm on a rant, but here we are. Like, if there are things that you don't believe in, how often do you go out of your way to jump into their communities and lecture them, rolling your eyes, insulting people, death threats? Like, you don't. Like, it doesn't occur to you. Like if you think dogs are better, you don't just smash around in a cat fancier forum yelling at people and making an ass out of yourself. And yet that's what the conspiracy theorists and the science deniers do. And so it's like, what is driving you to get to this point? It's crazy. It's like a religious fervor. And you are spreading the good news and you are saving the non-believers from eternal torment. That is the level of motivation that people have. And it's weird to watch it unfold, to be on the receiving end of it. And I'm, like, on the one hand exhausted by it and I ignore it. And on the other hand, I'm like a little curious. Like, what's going on in your mind? I want to know. So that's how I feel. And I don't know why, but I'm going to be talking to Lee on Monday. So I think we'll get a chance to talk about it. Anyway, it's weird. It's weird that this is part of my life. And I try to minimize the amount of my life that it is. And yet it's ever present. It is it's the hazard of doing this job. And it's weird to me. All right. Anyway, I'm losing my mind. So let me focus on space, because that's why you're here. Josh Russell, will NASA run out of shuttle engines for the SLS, or are they building more? Yeah, they're going to run out of engines. So the Space Launch System, the rocket engines at the bottom of the main module of the SLS, those are RS-25 engines, and those were originally developed for the space shuttle. They're a hydrogen rocket engine. They are incredibly efficient. They're the Lamborghini, the Ferrari of rocket engines, and NASA put all of this work to try and squeeze every little piece of efficiency that they could to make these rocket engines do the main job of carrying the space shuttle orbiter to space. And I've mentioned this in other times, like, the space shuttle was more powerful than the Space Launch System. The space shuttle was an amazing machine. It's just that it had to carry the orbiter to space, and then the orbiter had a payload. And so you lost most of that payload capacity by just launching the orbiter to space. But with the SLS, it's really a redesigned version of the space shuttle designed to carry more payload and less orbiter. But at the bottom of the main stage, it's using those RS-25 engines. And the difference with the space shuttle and the SLS is that the core stage of the SLS will crash into the ocean and destroy those beautiful Ferrari engines each time. And I think they have 16 of them, so they've got enough for 4 launches. And then once those are done, Aerojet Rocketdyne is going to have to get cranking and build them more RS-25 engines so they can crash them into the ocean. So sad. Gordon Chin, is there some way for normal people to do SETI with detection methods other than radio? That's a really interesting question. So yes, I'm going to say yes. So obviously the radio telescope is the way that people have been using for SETI. You listen to the signals from another star system, and hopefully you're going to have intelligent aliens sending ones and zeros, or the isotopes of hydrogen or pi or something like that. But there have been lots of other ideas proposed for SETI. So the one that's probably most likely is called optical SETI, or OSETI. And what that would be is, instead of the aliens sending a radio signal towards us, they're shooting a bright laser at us. And then hopefully they're hoping, they're going to target the laser right at planet Earth. And they're hoping that we will be watching the sky with our telescope, and we'll watch this star brighten and then dim in a very weird, artificial way. And that is the kind of thing that you could detect with a telescope. As long as you were the one looking at that star, measuring the brightness of that star over time, then you could detect that signal as it's being sent to us. The thing is that nobody is looking at all the stars all the time. Some people are looking at some of the stars some of the time, but you can take a star and you can watch it with your telescope night after night after night. With a fairly accessible tool for detecting the brightness of the star, you could track the brightness of a star. You could detect exoplanets passing in front of the star, just like with the TESS instrument, the transit method. And you could detect some kind of weird laser signal that's being sent from that star. So a related idea is that if you are detecting the transit method, you're using your telescope, you're watching the brightness of a star, and you're watching as a planet passes in front. If the technological civilization is big enough, they've built some kind of satellite that's like a triangle or something really weird, a weird shape, a megastructure that is passing in front of the star from our perspective. And you would see this weird light curve as this triangle passes in front. And there's no shape in nature that could create that shape, that light curve. And so you would have a really good shot at detecting planets. So you can see it's very much related to get a telescope, choose a star. And like amateur astronomers who get their own telescope, and they get some, and it's not like a huge expense. Like you can spend a couple of $1,000s, and then you can sign up and you can confirm candidate exoplanets that have been found by, say, TESS or other instruments. And you can actually observe those planets, or you can observe the change in brightness. So that's kind of like 2 ways. And I'm sure there's other ways as well, but like that's 2 ways that you could just imagine. Like you're out there, like there's a movie here, right? You're out there every night and you're scanning, you've chosen your star because you think that's the one that has planets orbiting around it, and you're watching and you get this weird signal. The star is changing in brightness and you're able to decode the signal, and it turns out it's an alien species that's sending us a message. So that could be you. All right. Well, those were all the questions that we got this week. Thank you, everyone, for asking them in the YouTube comments, as well as joining during the live show. Another reminder, we do this every Monday at 5 p.m. Pacific time, so you should come and join us. All right, we'll see you next week. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so that you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. And most recently, we had an interview with Nancy Graziano, the executive producer of the Weekly Space Hangout, the cat herder-in-chief who is here right now helping organize all of the questions and get them in front of my eyeballs. So if you want to hear how Nancy came to the system and the universe today, cosmoquestosphere, and what her vision is, you should definitely listen to that episode. That's on the podcast. Thanks to all the moderators, and a special thanks, as always, to Chad Weber, Nancy Graziano, and Anton Posnikoff.